let's say we have a function u and v with continuous partial derivatives. So dou u by dou y, dou v by dou x, and dou v by dou y exists. Now when we take the determinant of these, so dou u by dou x, dou u by dou y, dou v by dou x, and dou v by dou y. When we take the determinant, this determinant is called the Jacobian, or it's also called functional determinant of u and v with respect to x and y. Okay, now this is two functions, two variables. We could always have more than two as well. So instead of saying Jacobian every time, what we can do is we can write it like this: uv by dou x comma y, or we can write it as Jacobian. Yes, so this is the shorthand notation for talking of a Jacobian. That is the determinant. Okay, so if we have more than two variables, let's say more than two functions with more than two variables, the only thing is the determinant becomes bigger and bigger. Say for example, if we are talking of u, v and w with variables x, y and z. Now what will happen is the determinant would become a 3 by 3. Now remember, u with respect to x, with respect to y, with respect to z. So dou u by dou y, dou u by dou z. Now with respect v with respect to x, y and z. So dou v by dou x, dou v by dou y, dou v by dou z. And now with respect w with respect to x, y and z. So dou w by dou x, dou w by dou y, and dou w by dou z. Okay, so let's do a few problems based on this. Let's say u is a function of x and y, and v is again a function of x and y. So we have to find the Jacobian. So Jacobian would be with respect to x and y. So dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. Now let's find this. Dou u by dou x is equal to what? With respect to x, so 1 minus y square by x square. Dou u by dou v. Okay, dou u by dou y with respect to y. So x is, there is no y in the first term, so that is 0. 2y by x. Okay, so dou v by dou x would be what? That would be minus y square by x square, and dou v by dou y would be 2y by x. Now let's substitute into our formula. Is equal to, now this we can take LCM and say x square minus y square. So x square minus y square by x square, 2y by x minus y square by x square, 2y by x. Now let's evaluate the determinant. So x square minus y square by x square times 2y by x minus into minus, so plus 2y by x times y square by x square, or to be more clear, minus. So here let's multiply it off 2x square y minus 2y cube by x cube plus 2y cube by x cube. Denominator is same, so these two gets cancelled, and we are left with 2x square y by x cube. This and this gets cancelled. 2y by x is the Jacobian. Okay, let's do another problem. X is equal to r cos theta, y is equal to r sin theta. Now what we have to do is, okay, one more, z is equal to z. Now we have to find the Jacobian of x, y, z with respect to r, theta and z. Now let's take the first one, r cos theta. Now dou x by dou r is equal to cos theta. Dou x by dou theta is equal to minus r sin theta, and dou x by dou z is equal to 0. Okay, now let's do for y is equal to r sin theta. Now dou y by dou r is equal to cos theta. Dou y by dou theta is equal to r cos theta, and dou y by dou z is equal to 0. Z is equal to z. So dou z by dou r is equal to 0. Dou z by dou theta is equal to 0, and dou z by dou z is equal to 1. Okay, so now let's find the Jacobian. We know x comma y comma z by dou r, theta and z is equal to the determinant. Now let's do the substitutions. Cos theta minus r sin theta 0, sin theta r cos theta 0, 0, 0, 1. Now what we'll do is, normally what we do is we take the top row and do the determinant. Now to simplify the whole calculations, let's take the last column, or we can take the last row, because then two of those terms will totally become 0. 0, if we take this, then this whole thing becomes 0. Then we take this, these two, then these two becomes 0, and we are left with this. So 1 times r cos square theta minus into minus plus r sin square theta. Common is r, so cos square theta plus sin square theta, which is r. Let's do one more. X is equal to r sin theta cos beta. Y is equal to r sin theta sin beta. Z is equal to r cos theta, and we have to find the Jacobian. Okay, now let's do this. Dou x by dou r is equal to sin theta cos beta. Dou x by dou theta is equal to r theta, so that is cos theta cos beta. Dou x by dou beta is equal to r sin theta sine beta with a minus sign. Okay. Now let's do dou y by dou r is sine theta sine beta. Dou y by dou theta is equal to theta give you r cos theta sine beta. Dou y by dou beta is equal to r sine theta cos beta. Dou z by dou r would be cos theta. Dou z by dou theta is equal to dou z by dou theta will be r sine theta minus sine. Dou z by dou beta is equal to 0. Dou x comma y comma z with respect to dou r theta beta is equal to, okay, so dou x by dou r, dou x by dou theta, and dou x by dou beta. Dou x by dou, no, not x, dou y by dou r, dou y by dou theta, dou y by dou beta, and finally dou z by dou r, dou z by dou theta, dou z by dou beta. Now let's do the substitution. Dou x by dou r. Dou x by dou r is sine theta cos beta. Dou y by dou r, sine theta sine beta and cos theta. Okay, now next is r cos theta cos beta and r cos theta sine beta and minus r sine theta. Finally minus r sine theta, minus r sine theta sine beta, r sine theta cos beta and 0. Okay, let's look at this now. Okay, now here you have to be very careful while doing this. Okay, now what shall we do? Let's take let's first evaluate it, simplify it. Now let's look at this and this. R square sine theta, let's take it out. So we are left with, no, let's take sine cube theta. So what is left is cos square beta plus sine square beta, then plus r square sine theta and cos square theta. Let's take it out. So what we are left with is no, not cos. Now here I have made a mistake. Cos square theta, from where did, no, not this, this is here. Cos square theta sine theta and cos square beta. I did say that we have to be very careful. So now what happens? Cos square beta plus sine square beta. Now this and this are 1. So what we are left with is sine cube theta plus r square sine theta cos square theta. Okay, now let's take r square sine theta out. So we are left with sine square theta and plus cos square theta. Again this is 1. So we are left with r square sine theta. This is our Jacobian. Okay, so as I mentioned, and I have been mentioning this repeatedly, calculus, just a few steps would be calculus, and the rest of them all would be your normal algebra, trigonometry, and all that. So it is very natural to make mistakes, especially when it is a little bit complicated like this. So every step when you write, just very quickly verify it. Okay, so I think that's enough for today. Bye for now.